Okay, so here we have returned. We hope you had a great time, and we're all, oh, my visual aid we had for those who tune in later, see if they get the idea. Hopefully they had a chance to do this. So then, as they're pondering this, they might not get it, but what does this mean again?
Recharge.
So hopefully they had a chance to recharge then. Okay, so a lot of this I still need for the biology class, physical science, but this does pertain to you, what we see up here. So we've gone through your 5 reactions, which are what? Double replacement.
Single replacement.
Single.
Synthesis.
Decomposition. Combustion.
Okay.
Yes.
So then, when we hand this out, I want you to pay attention to this, because some of these you have to finish the equation, okay? But if you're just given fragments of that, you have to know what type of reaction that is in order to finish it. So in your estimation, is what part is the most difficult? Finishing the equation, balancing it, classifying it, all of that, the oxidation part, the reduction.
Oxidation reduction, I feel like. But I think I got it. It's just
Okay.
Like how you know like what goes with what. So finishing.
Okay. So we'll try to do both of these here. So, for instance, if we had, okay, someone give me a transition metal.
10.
1 moment.
It's not quite a transition
I got
metal,
one.
but
We'll do vanadium.
but we can use tin. That's what I heard first. Is that what you want?
Yes, we'd like to.
Okay. So then, what does that tin have for a charge?
-4 plus 2 and plus
Well, which do you prefer?
plus 2.
Okay, so this tin's got a +2 charge. You got to remember that. Okay. So then we're gonna throw this in some acid then. So some hydrochloric acid. And you had said it's as far as finishing these with the charges, for instance. So we're telling you, oops, that is a single replacement reaction. Okay? So SR would go up here. So then, in order to finish that right side, we need to know what's on this side. It tells us, but we need some symbols and letters, and you can say charges and things like that. Okay. So the symbol 410. For the stannate ion is what it is. And then, does anyone know what hydrochloric acid is?
HCl.
How do you know all the acids? Or are you just giving it to us?
I think we were told that we should know those. Yes, yes, yes. Hydrochloric, sulfuric, phosphoric. Those are 3 acids that we should know, okay? Because, so when you look at that,
I think I know the answer.
because what does this have for a charge? Negative what?
I got that. -3.
Okay. And then what does hydrogen have for a charge? Okay. So since those don't add up to 0, how many hydrogens do we need?
3.
And what element do we see right here in the middle? So what acid would you guess that is?
Phosphoric.
Phosphoric acid. Okay. Now, when we say hydrogen chloride or hydrogen phosphate, yes, that's true, depending upon what it is that we're doing with that, because this can be a liquid, it can also be a gas, but in this case it's a liquid. If it's phosphoric acid, it would be a liquid. So then, what is this ion? Well, it's going to be sulfuric, but what's this sulfate with a negative what charge?
2.
Okay, and then if we put hydrogen on here, how many hydrogen atoms do we need? And since it's got sulfur in it, it's what?
Sulfuric.
Sulfuric acid. Okay? Then, do we need to change anything here?
No.
No. And since it's got chlorine in it, okay,
How many are there? Just the amount of.
we'll just keep it to these 3. Okay? So then this would be your hydrochloric acid. Okay.
So basically, if you add the hydrogen to an acid.
Isn't it
No.
OH?
Because you can also have hydrogen chloride where it's in a gaseous form. Okay? So what you're going to encounter in college then is, we know that tin is a metal, so that's what we call it's in a solid state. This being an acid, it's going to be in a liquid state, because if we put a G in here for gas, then it wouldn't be hydrochloric acid, it would be hydrogen chloride. Okay, so now in this single replacement reaction, what is going to go over on the other side?
10.
Okay? Okay, so now this is going to be in a solution now. Okay, or liquid, and then what do we have left over? Okay, so then hydrogen in a gaseous form. Okay, so a lot of this is something that we don't spend a lot of time on this. Okay, just on account of you're probably going to have to work that out when you get into college, because yes.
Spell sulfuric acid.
Okay. All right. So then, now, is that equation complete?
We brought the H2 over because of why? Why is it H2?
Because it's a gas.
So all the,
But it's
oxygen is
Gases and
atomic.
halogens.
Mm-hmm.
How many tins are in that first set of?
That's why we asked earlier.
2.
Okay? So it's got a charge of +2. So does that mean, are we done here?
No, you have to put 2.
We are not.
So,
Need a little more room.
The left side just stand on its own. It has a +2 charge.
Because it says 0 right
it
now.
has an interaction.
Well, it's 0 right now because we asked if you wanted +2 or +4. We chose 2. It has to go through this process. Then it's got a +2 charge. Yeah, because over here, it's 0.
So it's just stable on its own.
Yeah, because you can certainly pick up tin and no problem. It's safe to handle because it hasn't, and it's on its own. It hasn't ionized with anything. Okay, so then on this side, okay.
How come we don't do the numbers underneath the arrow like we did when you were younger?
Oh, I didn't think we were that far yet.
We're not.
We're not.
So just let them teach.
Okay. So we say go by the negative ions. So which one of these has a negative charge? Which is what? -1. And this is where it's important. We said, is it tin 2 or tin 4? We said 2. So this has a +2 charge. And notice that doesn't add up to 0. So what do we need to do?
Find the common multiplier,
Which is 2. So then which one of these gets a 2? Okay. All right. So now, do you like doing the balancing in your head by adding coefficients, or do you want the numbers written below like requested earlier?
Just do
You can just do trial and error to balance it, or do you want the numbers written below?
You should show us what the other way is, like the numbers below.
Okay? So what that means then, what elements do we see in this reaction?
Hydrogen.
Hydrogen's on the left side.
One.
Hydrogen's on the right. Tin's on the left.
One.
Tin's on the right.
One.
Chlorine's on the left.
One.
Chlorine's on the right. Okay? So you can do this process. For some people, if that's what works for you, I would suggest continuing to do that. Or you can just do trial and error. And before you even get to this stage, in physical science, I recommend you doing that. But when we're at this level, I think we would agree you can just look at this and say, okay, without this, we got 2 chlorines on this side and only 1 over here, so what do we need to do?
Just put a 2 there.
And notice we're killing 2 birds with that proverbial killing 2 birds with 1 stone. You could have looked at this and said, we got 2 hydrogens on this side and only 1 over here. So then by trial and error, you put that 2 in there, and then it's now balanced. Because when you distribute this through here, that 1 gets changed to a 2. This 1 gets changed to a 2. So now you have everything balanced on both sides.
So then the tin on the left side and the tin on the right side, is that oxidation? Reduction?
We're not that far yet. Okay? So, are we okay with balancing this? Because notice, we're not doing this for all, there's 15 equations. You're not doing this for all of them. But I think it's important to have a good, hopefully, understanding of this moving forward. So now we don't need this down here anymore. Okay, so as we look at this, now we need to put the charges in. Okay, so we already know this is -1, that's +1. And then this over here, does it have a charge now? Okay, so it's at this point in time, now we can make this determination. Okay, so this it doesn't have a charge. It's stable, it's safe to handle, you can pick it up, and nothing happens. So the tin on this side went from 0 to +2. So then, and you don't have to, I think this maybe helps, just showing what has happened on one side of the reaction to the other. So did this gain or lose electrons? It lost electrons. So when it loses electrons, what process is that? That is oxidation. Okay? Then, when we look at what's left over, which one of these ions are we not concerned about at all?
No.
Someone said chlorine. Why? You're right, but I think it's one thing I always actually say, why are you right though? Yeah, nothing changed. Even though I understand you got 2 of them over here now, but this was a -1, this is a -1, so nothing changed. So therefore, what happened to our hydrogen?
I lost a charge, but gained an electron.
So when electrons are gained then, what do we call that? That's reduction. Okay? Because it's one thing we can say. There's different ways of looking at it. The charge got smaller because it lost an electron. So that's one way of saying electron, or so an electron was certainly gained. So when that happens, the charge got smaller, so it got reduced. Okay. Then, and maybe we'll just mention this for now because we're going to add something new to this. And that's where you say, yes, more content, as if this wasn't bad enough. This isn't bad. Hope not. Okay. So what this means is, okay, since this went through oxidation, this is what caused that oxidation. So this is what we call an oxidizing agent, the HCl. Okay? Then what we see happening is, since this went through the process of reduction, well, then the tin must be the oxidizing agent, or excuse me, the reduction agent. Okay? But we're only going to mention that. We're just going to say that once, just because you're going to run into terms like that. Nope, I did that wrong. This is the reducing agent. This is the oxidizing agent. There we go. You just remember, you got to flip them around. Since this is oxidation, you just say, well, then this is the reducing agent. Since this is reduction, then this is the oxidizing agent. Okay? And I think it's one of those things to where, okay, it's how you prepare yourself. Because why do we watch film in basketball, football, and volleyball? You don't do it just to waste time. Why do you do that? To prepare yourself. Because if you can see it on film, chances are once you see it again, then you're prepared for it. That's why we just want to mention that. But on these, okay, and I'll hand that paper out, we want you to be able to denote what's being oxidized, what's being reduced. Okay, so I'll just get rid of these so we don't get totally confused. So,
No, that's why he erased it.
correct. Okay, so front row, middle row, and back row. Okay, so of the 5 reactions, completing them, balancing them, and again, you're not doing this for each and every one of those, okay? Because
Wait, what do those numbers mean?
these here,
Yeah.
because when you look at number 2, okay, on the second problem, you just have half of the reaction. How do you know? I mean, chances are you can look at this and you would know it's double replacement because there's 2 compounds on here. Because the tattletale sign of when you see just one metal or one substance by itself, it's not double replacement, but rather single replacement. And then when you have a hydrocarbon combining with oxygen, that's probably what takes place in your vehicle. From octane, that's combustion. Then when you have something breaking apart, it's decomposing, it's decomposition. Or if you're making something, you're synthesizing it. That's right. Okay, so that was 18 minutes and 42 seconds, 43, 44 seconds of well-spent time. The only reason I know that is because I'm looking at the clock at the bottom right now. So we're about up to 19 minutes.
So number 7 would be a synthesis reaction. Is that right? It's still
Yes, because again, you are not given enough information. You would have to know that it's a synthesis reaction so you can complete the equation. Okay, so we'll just hit pause for just a moment. Okay, so a little bit of context again. Okay, so now that you have this paper, when you're looking at 2, 3, 5, 7, 10, and 12, 2 and 7, you have to know what type of reactions they are. And then if it has an asterisk next to it, we want you to do this process of oxidation and reduction. So, and I know this is difficult. So what I would suggest is go ahead and pick one of those that we can work on together, so then you have a little bit of aid to help you out. Okay, so number 10. Okay? So then looks to me like we've got some magnesium chlorate, okay? So we have some MgClO3. Okay, now, one of the things, we're going to say there's some breadcrumbs on here that can help you out a lot on a separate problem. Okay, the reason I say that is you probably don't know what the charge of the chlorate ion is. But why are you right? Because you're correct.
Because oxygen is -2.
No, when you put it that way, that was just a lucky guess.
Oh, -2 and a -1. So you have a -2 and a -1. Holy cow. And then it just,
No,
you know.
no.
Yeah.
Maybe she did guess.
I did guess.
Okay, so let's use logic. What's an alkaline earth metal? No.
That would be like say
Brass.
magnesium or
Beryllium.
beryllium.
Calcium, beryllium, magnesium. Main thing is they're in column 2. So since it's an element in column 2, you know what that charge is. That's why we had to ask you, what do you want for a charge for tin? Because you don't know. We selected 2, which is fine. So we know, typically we say always go by your negative ion, but sometimes if you know this is a +2, that must mean, since this is a 2 here, that this chlorate ion has a charge of negative what?
1.
Right, so -1 times 2 gives you -2. 2 times 1 gives you a charge of +2. So now we've got that balanced out, but the compound is already written out for you anyway. The reason we went over that is this chlorate ion is written somewhere else on this paper where you might not know what the charge is, but now we've established that by using this to help us figure that out.
Couldn't you just add up the charge like that part right there? Couldn't you just add it up?
Within the ion,
Yeah, oxygen has a -2.
okay? So then you can, and you're going to have to do that eventually, okay? So I think, why don't we balance this first, because that's something that we need to do, and maybe it's already balanced, which it's not. But there's not a whole lot to it though, either. So write the elements out, or you just want to use trial and error to balance it out.
Elements out. Write them out.
Okay, so what elements do we see?
Magnesium, chlorine, and oxygen.
Now, typically, chlorate is a polyatomic ion, but we don't have the chlorate ion over here, so we can't write ClO on both sides. So we have to break it apart into its assorted elements. Okay, magnesium's left.
1.
Magnesium's right.
1.
Chlorine's left.
2.
Chlorine's right.
2.
Okay, oxygen's left.
6.
Oxygen's right. Okay, so there's only one place that we can start, because knowing that we had 6 of these and only 2 of those, how do we get that up to a 6 then?
Times 3.
Okay, so the moment we do that, that's now a 6. Is it balanced?
Yeah.
Yes, it is.
So now we just put 1, 1, 1, 3.
0, 0, 0.
Or 0. Is it 1 or 0? It's 1.
Oh shoot, we got one too many blanks there. Okay, for number 10, there should only be 3 blanks, not 4.
So should we write in the third slot or fourth slot?
It doesn't matter.
Okay.
So 1, 1, 3.
1, 1, 3.
Oh, I put a 0.
Okay? So now, and
And it's a single replacement.
no,
Decomposition.
because this is really, really complex over here. If it's going to be a single replacement, you're using good logic because you saw this by itself, which is a good idea. But the problem with that is, if it's going to be a single replacement, you would have to have, I'm just using X as a variable, you'd have to have another substance here.
So single replacements always have to have 4.
Yes. Yep.
Do we have to put that down there? What kind of replacement?
What type of reaction is this?
Yeah. Do you have to?
Because the directions say place the appropriate abbreviation for each equation next to the blanks and then balance the following equations. Sorry, I didn't read the directions either because I already knew that we were going to do that anyway.
So it's decomposition.
It's decomposition, so we can just, on your paper, you have a little 10 there that has the 3 blanks, so you said 1, 1, 2. Just go ahead and put DC there. So I'm going to, sometimes I write it up here too, but write it next to the blank. Because like I said, there's a little 10 here because it's problem number 10.
Do you have to do the oxidation reduction?
Is there an asterisk by it? Yes. Okay. So,
So if it has an asterisk by it, yeah.
Well, one has an
But
asterisk
the
by
oxidation.
numbers 3, 5, 7, 10, 12.
okay. So as we look at this, we need to write the charges out for everything. And it was just a coincidence that you happened to pick the toughest one on here, which is fine. Okay? So what are our charges over here for the compound? That's the only way that you can do these. Plus 2, minus 1, and then 0. Okay? So what we see here, it's a type of decomposition reaction. We have a spectator ion in there. Which one is a spectator? You are right. Why are you right? Because it did not change. It's plus 2 and it's plus 2. Okay. This is where it gets to be difficult. That's why I said maybe you're lucky you happen to pick the most difficult one on, which again is fine. Because when we look at this, this whole thing has a charge of -1. Okay? So then that must mean that one of these has a positive charge. Oxygen will always have a -2 charge. Doesn't matter, always has a -2 charge. Okay? The only time that that's different is if you have hydrogen peroxide. This is not hydrogen peroxide for one. We don't have any hydrogen in it, and that is this substance. Certainly we're not going to get that confused. That's the only time you would change the charge of that oxygen. But it's not hydrogen peroxide. Okay. So, what do we say the charge of every oxygen atom is? -2. Okay? And how many of those oxygen atoms do we have? So that must mean that if this here is a -6, what must that chlorine have for a charge to equal -1 for the overall charge? Now, don't worry about this here. We're just +5, okay? That's what makes this so tricky. So I should probably be glad that you asked this question, okay? Now, why are we doing this? Well, in 2 years from now, I'm going to pick on 1, 2, 3. You could, but I don't think so. And then in college, I'm talking about, or technical school. Is this something that you would be doing in college or technical school? That's why I said probably yes and yes. And I think so. And I don't know. Maybe. Yes. College? Okay. So just imagine you're walking into all of a sudden it's, usually it's Monday, Wednesday, Friday. Okay, so on the syllabus it says I'm just picking, I know Veterans Day was on a Monday. So on the schedule it says on Wednesday, November 13th, we're going to do oxidation reduction reactions. Okay? But you don't even know what that means. Well, we didn't do that in high school. Well, I don't think your college professor is really going to care. He might. Oh, we're going to clean our eyebrows. Clean our eyebrows. Maybe not just you. You too? I don't know.
What are we talking about?
Clean your eyelashes.
Why would you? I said eyebrows. I got it wrong, didn't I?
Oh,
Clean
yeah.
your eyelashes. Sorry.
Yeah, probably.
Make them a little bigger.
Yeah.
So that's something you could talk about to get rid of that awkward silence.
Yeah. My boyfriend will also tell me to shut up.
Now,
Nice guy.
normally I would say that that's rude, but knowing some of the conversations that we've had in here, it might not be. Okay.
It's sometimes justified.
Okay. Well, at least we admit it then. Okay. So on that Wednesday, November 13th, you said, oh my gosh, well, I don't know what's going on here. Okay. So as we're looking at this, now that we've got these charges established, okay, now we can start to figure this out. Okay. So what you need to do is pick, we know it's not this because that did not change. This did not change. So that just leaves your chlorines and your oxygens. So what do we see happening? Chlorine went from +5 to a -1. Okay? So does that mean it's gaining electrons or did it lose electrons? Yeah. It gained electrons, but it didn't gain, yeah, it would gain 6. Okay? So when electrons are gained, we call that reduction. Okay? Then, what happened to our oxygen?
It oxidized.
Okay? That went from a -2. So, is this number getting bigger?
Yeah.
Or small? It is. So then, when you say oxidizing, that would be correct. Okay. I think just doing this, or maybe beneath, put ox equals oxygen and red or reduction equals chlorine. I think that'd be the simplest. Okay, so we're up to 32 minutes. I think that's enough. Tomorrow, you're going to be given time to work on this, and it's not the only day because this is hard stuff. Okay, because not only did you learn this in physical science and a little bit in chemistry, you're taking that just a little bit further. So tomorrow, I'll have time to work on these. We'll catch up to you next time.